So this video will be all about my second vlog of my SPH4U course, and the main content of this video is to explain one question, which it says a person decides to swim across a river which is 84 meters wide that has a current moving with a velocity of 0.4 meters per second moving east. So east and west is the x component, the direction, right? So it's basically telling us the horizontal velocity. And the person swims at 0.7 meters per second north, which tells us the vertical components of the velocity relative to the water. So the first question is asking that what is the velocity of the person with respect to Earth? This is actually asking us like its speed, its velocity, not speed, sorry, its velocity. You don't have to take that much attention on respect to Earth because it's just you can understand it as unrelative to the water. So just consider the man itself. And on the left side of this picture is basically a graph of the motion. So as you can see, the river is 84 meters wide, and I have added the velocity of the person and the current. So there's an angle theta, which theta is the angle between the y component and the velocity. So let's look at the first question. What is the velocity with respect to the Earth? We need to apply GRASP method, with which G that we know the horizontal velocity is 0.4 meters per second moving east, while the vertical component is 0.7 meters per second pointing north. And this question is actually asking us the resultant velocity, total velocity, which we can simply apply Pythagoras theorem that the velocity, the total velocity equals to the root of the sum of vx squared plus vy squared, which by substituting the values we can gain that sigma v equals to the root of 0.4 squared plus 0.7 squared, which actually equals to 0.81 meters per second. And actually, after calculating the magnitude, we need to calculate the direction, right? So how can we calculate direction? Just simply use the trigonometry by applying trigonometry, right? And so tangent theta equals to the opposite lane divided by the adjacent lane, right? So tangent theta equals to 0.4 divided by 0.7, and by using the reverse of trigonometry we can gain that the angle is actually 29.7 degree. So the final answer should be the velocity is 0.81 meters per second pointing north, which has an angle of 29.7 degrees to the east. And let's look at question B. How long does it take to cross? This is quite simple actually, that we also need to apply GRASP method, which the distance traveled is 84 meters, while the horizontal component of the velocity equals to 0.7 meters squared point east, and it is actually asking the time, which the formula that we need to apply here is displacement equals to velocity times time. And by simply applying the values, we can gain that 84 equals to 0.7 t, which by using calculator t equals to 120 seconds. So the final answer is it takes him 120 seconds to cross the river. And as you can see on the right of the picture of the PowerPoint, there's actually a 2D dimensional graph of this motion that we can simply understand why I do this calculation, because the distance calculating here is only about the sorry, not dx, is actually dy and by. I just made some mistake on writing, okay? So on the north and south direction, it's the vertical component of displacement, and also 0.7 meters per second pointing north is the vertical components of the velocity, so that we can simply do the calculations by that. So let's take a look at the third question. It says, how far downstream will the person land? And this is actually asking the horizontal component of displacement, like how far the person moves to the east because of the current. So by applying GISP method, we can the data that we know is firstly the horizontal component of a velocity, which is 0.4 meters per second pointing east. And sorry, I just made a mistake on writing here. I write directly like Vy, but actually it's Vx, and also the direction is east and not north. And also we know that t equals to 120 seconds, and the unknown value that we don't know, we want to know, is delta dx actually. And the formula that we need to apply is delta dx equals to delta, no delta here, equals to Vx times t. So by simply substituting the values, we can gain delta dx equals to 0.4 times 120, which equals to 48 meters. So the distance downstream is 48 meters, pointing east actually. And now let's came to the final question, So finally, let's go through the last question. It's asking that in what direction should she swim if she lands at a point directly north of her starting position. So there's a graph that I draw myself, because this question is actually asking the opponent direction, like the opponent angle, because the person is directly, his vertical component is directly to north. So, but the current is bringing her to the east side. So there need to be a component that is opposing the east side, which is pointing west. So the angle here, which the velocity had, the angle between the velocity and the x-axis on the left should be opposing 0.4 meters per second, because it's pointing east. So let's start to explain this question. By also applying GISP method, we can gain that Vy equals to 0.7 meters per second. But this is actually not quite the, like 0.7 is not only the vertical component here, because there's angles, so just use V, okay? And the horizontal component of velocity equals to 0.4 meters per second. And this angle between the velocity and the x-axis on the left, I call it theta dot. And we need to know that how much equals to theta dot. And the formula or the concept that we need to follow is only trigonometry. So by simply substituting the values, we can gain that cosine theta times 0.7 equals to 0.4. That we need to have a balance, to make it equilibrium, right? So cosine theta equals to 0.4, like divided by 0.7. And after calculation, we can gain that theta dot equals to 55.2. And because this is because the x-axis on the left is actually the direction west, so the direction should be west and 55 degrees pointing north. So this is the end of the video, and I have explained all 4 questions of question 7 that someone gave us on during class time. So yeah, this is the end of the video. I hope you like it. See you next video. Bye.